Okay, so today we are talking about converting between moles and particles. So particles is either atoms, molecules, or formula units, which we see right here. And mass is obviously grams. So in this case, we're going to combine what we did in EQ number 4, which was the molar mass conversion factor, and what we did in EQ number 3, which was moles to particles. But the steps are all the same, and we're just going to work our way through it step by step. So step 1, we're going to draw our dimensional analysis setup, doing problem number 6 here from the homework. Our next step is to identify what this question is asking for. So this question is asking me for atoms. Total number of atoms in 34.8 grams of beryllium acetate. So that's my ending unit. I am trying to get to atoms. The next question, or the next step, is to identify my starting point. And I see right here that my starting point is my given 34.8 grams. 34.8 grams of beryllium acetate. Unfortunately, we have been given the formula, but we should know how to find the formula. Beryllium has a positive 2 charge. Acetate has a negative 1 charge, so it's BeC2H3O2, 2. I want to put my formula there in my problem. BeC2H3O2, 2. Okay, so now my next step is identifying the conversion factors that I need. And for that, I'm going to look for certain key terms that exist in my problem. Here, my question asks me for atoms. As I know, atoms is a particle. That tells me, I'm going to look over here at my reference sheet, that tells me I'm going to need conversion factor number 1, the moles to particles conversion factor. All right? Anytime, just like we did back here in EQ number 3, anytime I am going to use the number 1 conversion factor, I want to ask myself, do I need the 1B conversion factor? This question is asking me for atoms. I am working with beryllium acetate, which is a formula unit. It's an ionic compound. Anytime I have atoms and formula units, or atoms and molecules, then I also need the 1B conversion factor. So in this case, I need the number 1 conversion factor and the 1B conversion factor. But I'm not done yet. I want to look for other key words. I see the word grams here, right? It gives me 34.8 grams. That's my given. That tells me that I need the number 2 conversion factor, the molar mass conversion factor. I'm going to go ahead and make the number 2 and the number 1B conversion factor so that I have them to look at. The number 1 conversion factor is already written out for us. So in 1, so this is 1B, in 1 formula unit of beryllium acetate, BeC2H3O2, 2, there are how many atoms? So again, this 2 is going to distribute, so I have 4, 2 times 2 is 4 carbon atoms, 2 times 3 is 6 hydrogen atoms, 2 times 2 is 4 oxygen atoms, and 1 beryllium atom. So that is 15 atoms in 1 formula unit of beryllium acetate. I want to have that written down so I can refer to it later. I also want to go ahead and write down number 2. In 1 mole of beryllium acetate, I need to calculate the mass. So I'm going to go and look up all of those values on my periodic table, and I will space those out. So I have one atom of beryllium, which has a mass of 9, plus carbon, which has a mass of 12, and there are 4 carbon atoms, plus hydrogen, which has a mass of 1. There are 6 of them, plus oxygen, which has a mass of 16, and there are 4 of them. So when I add all that up, that is going to give me the molar mass of beryllium acetate. and that is equal to 127 grams of beryllium acetate. That's a 3 there. Okay, so again, these values come from the periodic table. The atomic mass of beryllium is 9, the atomic mass of carbon is 12, and so forth. And for simplicity's sake, we just round those values for this class. All right, so now that I have all of my conversion factors, now I can go to my problem and plug them in. Here I have grams of beryllium acetate, so I am going to choose the number 2 conversion factor that I have written right here, because I need grams to cancel out with grams. So grams will go on the bottom, 127 grams BeC2H3O22 in 1 mole of BeC2H3O22. All right, but I want to get to atoms, so I'm not there yet. So I'm going to add another conversion factor. So again, now I'm in moles. I want to get to moles. This has formula units and atoms. I can't use that. Here's moles right here. So I'm going to use the number 1 conversion factor. So in 1 mole of C2H3O22, there is 6.02 times 10 to the 23rd formula units of BeC2H3O22. I've run out of room. I'm going to extend this a little bit. All right, so now I'm in formula units, and again, beryllium acetate is a ionic compound, so it's a formula unit. I can't just call this atoms, right? We're talking about beryllium acetate. So now I'm going to use my 1B conversion factor to convert from formula units to atoms. Whoops. So in 1 formula unit of beryllium acetate, there are 15 atoms. And now I can check and make sure all my units cancel out. Grams cancel out with grams. Moles cancel out with moles. Formula units cancel out with formula units. And I'm left in atoms, which is the unit that I want to be in. So now all I have to do is go to my calculator, multiply 34.8 times 6.02 to the 23rd power, or times 10 to the 23rd power, excuse me, times 15, and divide that by 121. Oops, that's supposed to be 127 grams right there that we got from down here. So if I divide that by 127, I would get, whoops, did that again, 2.47 times 10 to the 24th power atoms in 34.8 grams of beryllium acetate.